Okay, let's talk about the Bohr model of the atom. So the Bohr model of the atom states that electrons exist in distinct energy levels outside the nucleus, and those energy levels are labeled with the variable n, okay? So these actually correspond to the periods on the periodic table. So the first period would be n equals 1, the second would be n equals 2, the third would be n equals 3, and so on. And the further away you get from the nucleus, the closer those energy levels get to each other. And if I've got an electron in my n equals 1 energy level, and I throw some energy at my atom, maybe through heat, and the electrons can absorb the energy. And when they absorb the energy, they jump to a higher energy state. So we're going to call this the ground state, wherever the electron began, which is n equals 1. Okay? It absorbs.
If you go to Brophy for 5th hour,
we have to hold for the announcement, so hold on 1 second so I don't have to restart the video.
Return to Xavier for the announcement of the homecoming court. So 5th hour, you will report to Brophy for the beginning of the class. They have been notified you will leave at 12:05 to come back to Xavier to be in the AC for the announcement of the homecoming court. Thank you.
Okay, so the electron jumps to a higher energy state. It could jump to n equals 2, it could jump to the third, it could jump to the fourth or fifth energy level. It all depends upon how much energy it was able to absorb. When it jumps up to a higher energy level, we say it's in the excited state. Okay, so now we're in the excited state, and the electron doesn't stay there forever. Okay, it has to come down. As it comes down, we say it's relaxing, and as it comes down, it emits the energy it absorbed to jump from the first energy level to the third energy level, and we see it as a band of color on an emission line spectrum. So the colors that you see from fireworks or from different types of light bulbs, those are all related to the electrons in the atom that absorbed energy and were excited. As they relaxed from the excited state, they emitted the energy that they absorbed, and you see it as a distinct color. The more energy that an electron absorbs, that means that you're going to get a shorter wavelength of color. So within the visible light region, you've got like blue, indigo, violet at the shorter wavelength end, and that means they're higher energy. Okay, so if you have an electron that absorbed just a little bit of energy to get from like n equals 2 to n equals 3, because those energy levels are closer to each other, it would emit a band of color that's closer to the longer wavelength end, like red, orange, or yellow, for example. Okay, so these emission line spectrums, which I've given you a picture of hydrogen, helium, and neon in your chapter handout, you see little tiny bands, okay, like little white bands, but if you open up this chapter handout in Canvas, you'll see them in color, okay, and they're separated by black regions. So you have these like discrete black regions with little bands of color that are separating, so we call this discontinuous. So emission line spectrums are discontinuous, and they're all unique for every element. They're like a fingerprint. The white light spectrum, which is up at the top here, okay, that is just a rainbow of color that is not separated by black regions, so we call that a continuous spectrum, okay? Now, something that you're going to need to know is all of the terms that I've talked about, like emission line spectrum, ground state, excited state, electrons relaxing as they come down from the higher energy level. You need to understand how everything relates to these bands of color that you see on an emission line spectrum. Okay, and we're going to do a lab on it. So it'll be really fun, actually. It's probably one of the best labs that we do during the whole year. So make sure you know that this is the Bohr model of the atom. I also need you to know that quantum numbers, which are numbers that are used to describe like the energy and the relative locations of electrons, you're only learning the first quantum number, which is the principal quantum number n, which has to do with the primary energy level that electrons exist in. And this is related to the period on the periodic table. Okay, and I'll show that to you in the next video. I believe the only other term that we talk about within this section of the Bohr model is quantized. So quantized means that it's fixed, it's at distinct levels. So like stairs are quantized, a slide is not. These energy levels are quantized where the electrons exist outside the nucleus. And I believe that's it. If you turn to page 6, I've given you a great summary at the top of all the major points of the Bohr model of the atom, so you can read through that. And I think you should take a look at student exercise number 12, pause the video, try to answer it on your own, and then check it with me. Student exercise 12 says, in one transition, transitions are what we call electrons that are moving between energy levels. Okay? In one transition, an electron in a hydrogen atom falls from the n equals 3 to the n equals 2 level. So n equals 3 to n equals 2, there's not a lot of space between those two energy levels. So that means that the electron didn't use a lot of energy to jump from 2 to 3. So it should emit a band of color that has a longer wavelength. In a second transition, an electron in a hydrogen atom falls from the second to the first level. The second and the first energy levels are further apart than the third and the second are. So that means it would take the electron more energy to jump from the first to the second in the second transition, and as it relaxes, it should emit a band of color that has a really short wavelength. Compared to the radiation emitted by the first of these transitions, the radiation emitted by the second will have, and I just gave you the answer, it should have a shorter wavelength because it took more energy. So the answer would be C. Okay, so now what I want you to do is the Bohr model worksheet, and you're explaining how line spectra originate, meaning you're in words explaining how electrons have the ability to absorb energy. You have to use all the proper terminology, ground state to excited state, they relax, they emit electromagnetic radiation in the form of visible light, which you see as a color. It's a band of color that you're going to see on an emission line spectrum, and the emission line spectrums are unique for each element. Something that we probably want to talk about is a photon. Just keep in mind that when you get to the lab, if you have one electron jumping down or dropping down from a higher energy level, it emits a photon. If you have 10 electrons coming down, then we would emit 10 photons. Okay? So just keep that in the back of your mind for later on.